Good evening, everyone. How are we all? And how was Hyperia? Absolutely fantastic. So I hope you enjoyed the ERT. So welcome back to this evening's event. For those of you watching online, welcome. Tonight's talk and Q&A with Mack Rides was part of Fearless Frenzy, an attraction source event at Thorpe Park. For further information and current and future events like this one, go to attractionsource.com/events. So without further ado, I'm going to shortly introduce Stephan and Maurice Kremer from the Track Development and Simulation Department at Mack Rides, who have flown over from Germany especially for the event today. The department revolves around designing roller coaster layouts and consists of 6 engineers with a broad range of skills and backgrounds who oversee the attraction projects at Mack Rides. From start to finish, their work includes early layout concepts, optimization of centerline geometry, way above my head, and layout dynamics for the coasters, along with the creation of detailed production drawings of the individually drafted track pieces and verification during ride commissioning. Wow. So Maurice was responsible for the creation of the layout design of Hyperia. One of Stephan's latest projects was the newest addition to Europa Park's awesome coaster lineup, Voltron. Who's ridden Voltron so far? Yeah. Phenomenal, isn't it? So please join me in welcoming Stephan and Maurice to the stage.
Thank you, Chris. And also thank you, Thorpe Park, for accommodating us over the last day and today as well. And thank you also for inviting us to this event. I think it has been so far very successful, and hopefully we won't bore you with our presentation right now. And if centerline geometry goes way over your head, Chris, I think you might be in for a ride, no pun intended. Okay, let's jump right in. Today's talk, we'll do a short introduction of ourselves and where we work and what we do at that company. Then Maurice will take over, tell the story about how Hyperia came to be here at Thorpe Park, which will be really interesting since those projects really lasted a long time, and there's a whole bunch of stuff to talk about. And after that, I will do a layout design deep dive, basically go a little bit deeper into the background of what we do at Mack Rides with roller coaster design, and also with track design in particular, because not only roller coasters need track design. So this will be the nitty-gritty mathematical, theoretical stuff, and I will try to boil down everything to make it more accessible to a broader audience. And after that, we are happy to take questions and answers. So, my name is Stephan I'm an electrical engineer by trade. I did a master's in computer engineering in 2015. In 2014, I already did a semi-year internship at Mack Rides in the same department that I'm in right now. In 2015, I actually started full-time in that department. Since 2020, I'm the deputy head of that department. And one of my main focus when I'm not designing roller coasters for particular projects is actually developing our own proprietary layout design software in-house. Yeah.
Yeah, also hello from my side. My name is Maurice Kremer, and I'm at Mack Rides since 2019. I did my master's in digitalization, bachelor degrees in mechanical engineering and industrial engineering, and besides the layouts we do at our department, I'm responsible for the development of the software that is responsible for the track data. So we develop the software, and also I'm responsible for the organization between the departments, everything that belongs to the track production.
Yeah, as you've already heard, Mack Rides actually produces all the tracks in-house, so everything is made in Germany. as Chris already introduced, we are 6 engineers, so 2 of us right now here and 4 of us in Germany. All of us are doing layout design for projects, and each and every one of us has like a particular topic that they do like 30% of the time, which is further development of like our softwares, etc. And yeah, for me it would be the layout design stuff, and then Maurice does all the track production tool chain. Yeah, where do we work? Our company is very old. Mack Rides was founded actually in 1780. And the company started with producing wagons for farmers and woodworkers in the Black Forest in Germany. And in the 19th century, there was like traveling showmen, and those guys arose in Germany, and they actually needed also wagons, and that was like a way to expand our business. So that's how we actually got into the amusement industry very early on. In the early 20th century, since we already had the contacts with the traveling showmen, they actually asked us if we could actually also build amusement rides. And so in 1921, we built actually our first wooden roller coaster. And quickly, like after the Second World War, expanded into steel roller coasters. The last wagon that we built was in the 80s or 90s of the 20th century. So we actually really had that business for a very long time. In 1975, Franz and Roland Mack founded Europa Park, which is now the biggest theme park in Germany. And the goal of that park was to showcase our products, the Mack products. And that was basically our place to show our prototypes for a very long time. Up until 2009, which was our first major steel roller coaster, Blue Fire at Europa Park, as you can see down there. This was also our first looping roller coaster, and also our first launched roller coaster. And in the following years, Mack Rides' product portfolio actually expanded so much that we couldn't do all our prototypes at Europa Park. So some of our prototypes in recent years have been not in Europa Park, like the Extreme Spinning Coaster in Silver Dollar City in America, or also the Power Splash, as you can see on the top right in Walibi, Belgium. Nowadays, our product portfolio is built on 3 pillars. That is roller coasters, our biggest pillar, with 70% market share. Water rides, that also includes water coasters, like hybrids of coasters and water rides. And dark rides and flat rides, which is actually expanding at the moment, since like storytelling and interactivity has currently a growing factor inside this industry. So we actually try to expand into more dark rides and flat rides at the moment. And without further ado, let's jump into the making of Hyperia.
Yes, already told, I was responsible for the layout of Hyperia, and I will give you some insights and from the first layout up to the opening, and we go through the development a bit. Yeah, we just start with our very first version you see here on the right. This is very different to what we have written today. But we just start with some version. It's at the beginning there's always the contact with the client, often with an RFP, so a request for proposal. The customer comes to us and says what they want to have. Here, for example, it was clear that it should be a mega or hyper coaster. And they say which target group, what do they have for budget, maybe how long, and everything we get from them, we work with this. So we try to realize the wishes of the customer by our layout design. So all in all, we had at the end 9 versions with different revisions. So all in all, I can't even say how much it was, but it were a few. Right. So let's just look into the first version. What's always important for us that we don't give the customer only hard facts like documents, budgets, or something like this. It's also very important to give experiences, to give an expression how a roller coaster could feel like, could look like, and that's a really good way to show this is by a movie, by a short video. You can't sell roller coasters only by facts and data, but also by thrill, by enthusiasm, and so that have to be shown. We also do in our offers often we show what we can additionally do. For example, here a spinning seat on a blue fire or a backward seat, and that's just for the customers to see. Maybe they are interested, maybe they are not. A really important thing is for me the on-ride, because the on-ride you really experience what you will get as customer, and so this is always part of our videos we make. If the customer, for example, want to have a special view in the landscape or something like this, we can always generate pictures and renderings from this side. So the customer can really imagine how the coaster will look like in their park. Especially this version number 1, wasn't made by me, it was made by a colleague. I jumped a bit later to the project and did some other versions that were a bit later. So just let's look at until the end. But we already see, it's not Hyperia, it's something really different. But that's what we do. So we start with the version, and at the end it could be that the final version doesn't have to do anything with what is built now. So in the end, we decided, or Merlin decided together with us, that version number 6 would be the version we go with. You even see here that this is still a concept and not the final layout, but this is the layout from the contract. You, for example, see here the curve out of the station, that this has changed slightly, and also the other elements. The shape is the same, but they also slightly changed a bit. What Merlin firstly wanted is a roller coaster where we start with a quite classic hypercoaster. So they wanted just a drop and a big airtime hill. But you can see here, there we were limited in the space, and we couldn't go any further to this. So we just decided to turn the drop and go in the opposite direction. And with this, we already had a quite unique element, and we knew we can't do a classic hypercoaster. We will do this just at the beginning with new elements, with modern elements, maybe unique elements. So this is how Hyperia was born. What was special, Merlin always wanted to have a lot of airtime in this ride, because they say Thorpe Park had a lot of inversion coasters, a lot of coasters that have inversion, but there's a lack of airtime. So we tried to do as long as airtime as we can, and this is also how this outer banked turn was born. Firstly, it was just an outside banked airtime, But yeah, I tried and tried to get more and more airtime and to have an element that had a really long duration of airtime. And yeah, so in the end, somehow this was born. So when we have the contract, we go over and go into the detailing of the layout design. We go through every centimeter and look that the layout is perfect at every inch, at every centimeter of the track. And yeah, the final version of this is a track log, or we say track log, because the track, the layout can be changed after that. Because if we would change this afterwards, all the drawings have to be renewed. We have all the documents have to be re-updated, and that would have a further impact. But yeah, in reality, it is also often after the track log some changes. But yeah, that's reality. What is really important also are these two drawings. I think these two drawings use the plan view and the contour line since decades, but it's still really important because you have to match the positions of the coaster with the customer. So everyone has to be clear, where is the coaster in the park, where's the position, where's the project origin, and this can be easily done by such drawings. Yeah, after the detailed layout, we also detail our ride simulation, and still what is our top priority, it's always that our roller coasters are safe. So what's really important is the risk and hazard analysis. The roller coaster should look like it's risky or thrilling, but in the end it has to be absolutely safe, and that is our top priority. Yeah, also during the detailed engineering phase, we look, for example, to the reach envelope on the left. We look that in the normal movement area of the passenger, there shouldn't be anything that could hurt, that could collide with the passengers, and yeah, that is shown here. We also do a multi-body simulation, seen here on the right, so we can push the whole train through the track and see what does the train do. And all moving parts have to be freely and have to be an offset to each other, so they don't collide, they don't touch, because yeah, that's something we want to look in before we do the first test runs, but because then it's quite too late. What is also done in the detailed engineering phase is that we do the design of the track, of the train, and the engineering of the train, and also the drawings and construction of the special track sections. Something like this. Here, for example, it's the trim brake, the final brake, and the lift. Everything was where equipment is inside the track. Yeah, one very important milestone is a column lock. You see here on the left our column iterations. We talk to the customer says us where we can put columns, where maybe we can't put columns. Here, for example, it was the Merlin didn't want to have any columns inside the lake, so inside the sea, and so we had to push the columns to a longer distance that we are used to. And yeah, so after a few iterations with customer, we have a track log, we have the column log, and after the column log, we can calculate the loads on the track. Which final result you can see here on the right side. Everything is calculated where cross beams are, where reinforcements are. For example, at the position where we have the longer distance of the columns, there we also find a stiffer track, so stiff reinforced tracks and higher thicknesses. If the detailed engineering phase has ended and we have calculated everything, we can start with the production. The columns are produced, we produce our trains, here seen in the right, and of course our track production can start. We in our department, as already said, are responsible for generating a lot of data for the track production. There we have different types of production. Some are more handmade manufacturing. So we have a drawing, and at the end, the worker realized these drawings. But others are more automatized. For example, here we use human-machine interaction. And sometimes we just generate data without any drawing, and the robots can work with this and create diagonals, etc. So just a quick example how a track is built. We just start with bending the rails. After that, our cross beams are milled or by CNC, or are reassembled, pre-assembled, and then were put into the rails. Was really important that we have a rail joining, so we always do a pair of two tracks together, join them, and look that the transition is really smooth, that we don't have any jumps, because that would cause vibration, etc. on the track later. We insert also the diagonals and weld the whole track together, and at the end we varnish the track to protect them against the weather, against sun, against water. Once the track has been produced, we start with the construction side. At the beginning, it just looked something like this, where the groundwork has already started. You see some foundations, and a few months later, it even looks like this with a ready track. So we build up the track, the columns. But I think on YouTube you find a lot of the backstage of the Hyperia content of the construction site, and I think that you have already seen probably. And at the end we put the train into the maintenance, and we are ready for the first test rides. When we do the first test rides, it's important that we have a good commissioner that hears and sees everything maybe a normal passenger wouldn't see. So the first test rides are really, you just look at the train, you just hear and control if you see something or hear something that is not normal. So this is just the first checks. After this, of course, we do accelerometry, we do acceleration measurements. You can see here on the top left the acceleration measurements in Z direction. So for Hyperia, and we look that all the train static is inside our borders. All the standards are reached, so we don't go over any borders. What we also do is, here you see our marketing goals, how long will be our airtime moments, and we see, for example, at our outside bank turn, we have told Merlin that it would be about 4.2 seconds. At our first measurement, we had about 5 seconds, so I think we have reached this. What is also special for this kind of coaster, because we have a lot of airtime, is this graph in the standards. You see the acceleration in Z direction, so your body axis over time, and this dashed line shows if you have acceleration and airtime that goes over 3 seconds, you have to be inside these borders. So this is special for this one because we don't have a lot of coasters that have over 3 seconds of airtime. Here we had to consider it, but everything went good because these two are the first two valleys, and there we should have only 2 seconds or 2.2 seconds of airtime just before. What we also do is validate our simulation. So does the simulation that we did match to our measurements we did? And also here it looked that we have done a quite good job. The simulation matches really good the real measurements. You always have to take in consideration that during commissioning the friction factors are quite high because the bearings are new, everything is new, everything has never ridden. So the track and the train will get faster and faster and is even getting faster now. Until summer we will see how fast we will get with the track. You just see on the right side our simulation and on the left side the actual on the right. And after all this work we have done and after all the enthusiasm we put into this project, it is time for the first manned ride. And these are two pictures from the first manned ride, and I had the honor to be on it and to experience this, and it was for me really amazing because you put so much work in this. You have ridden it 1,000 times on the computer, and now you can really experience it, so you can feel the accelerations you set years ago, and it's a real unique moment. So then we were ready for opening, and we saw just a few nice pictures. I hope you are as enthusiastic for Hyperia as I am. So, and you have enjoyed your ride, and that's it from my side. Stephan now will take a look into the layout design.
And Chris, if you are so kind and just give me a red card if I'm going too long or something. Perfect. Are you ready for the nitty-gritty stuff? Okay. Layout design. Mack Rides, as I've introduced earlier, is a manufacturer of many different kinds of rides. So our department also does a whole bunch of different rides, and that gives us a whole bunch of design challenges because, obviously, layout design is a very broad topic, and we have to accommodate very different ride types with basically our own development software, since we don't want actually to develop different kinds of software for different rides. So there has to be some broad range of pretty abstract concepts to accommodate for all those different ride types. And also for upcoming ride types, our other development engineers are coming up with right now that we are not even aware at the moment. So just to give you a big overview or broad overview of what kinds of rides we actually do in our department, and that really starts with something like this here, which is an Omnimover dark ride. And below those coaches are actually tracks. And since there's steel track underneath, we have to calculate the track. So this is basically the easiest kind of ride simulation or ride design that we do. since all those coaches are continuously moving all the time, those things have capacities that are out of this world, like 2,000 and more people per hour. But yeah, since there's just a constant velocity and pretty easy track geometry and mostly 2D layouts, this is basically the first or easiest kind of ride to design. Then, going a little bit further, our pod coaster, which is actually one of our most bought roller coasters, has an onboard motor. So it's not only propelled by gravity, or basically we try to avoid gravity by using our onboard motors. And that is actually a ride that's also here in Thorpe Park, Flying Fish, a very old Mack powered coaster, but still a Mack product. And that's also a kind of ride that we have to consider, which is not gravity driven and therefore needs special kind of calculations because the train velocity isn't determined by gravity. Then our smallest coasters are the kiddie coaster and youngster coaster. Those are family and kiddie type rides, which actually have their own types of constraints since they shouldn't be too thrill based, right? And that really boils down, or that really constrains the type of elements that we can do. We can't do outer bank turns and weird inversions on those types of rides. So, yeah, and that's a real big design challenge to come up with a really interesting and still fun family coaster and kiddie coaster. And a whole bunch of thought goes into those rides as well, since we want to do ideal and optimal products for all of our ride types. Then, even our most bought product in the last few years comes in all shapes and sizes. Like the original Blue Fire, our launch coaster in the bottom left, is a medium-sized launch coaster. We build these launch coasters up to 200 feet tall right now. This in the bottom right is a coaster in China, our fastest launch coaster, with, I believe, the fastest inversion in the world right now. And we use the same kind of trains also for our chain lift coasters, of which Hyperia is the newest addition. And also those chain lifts come in all kinds of sizes, with a medium-sized chain lift here, a hyper coaster which barely fits into the hyper category with 202 feet in Australia, and with the newest edition, which is actually our highest chain lift here, Hyperia. That's for traditional roller coasters where the train is really bound to the track. It's a traditional steel roller coaster. The train velocity is mostly determined by gravity after the chain lift or launch section. But we also do water coasters and water rides, and also those things have layout design. Especially the water coaster for the steel tracks, and the power splash, which is only steel tracks. But weirdly enough, those things also float in some kind of sections, and there's like free floating water sections, and we have to consider like the water flow and the channels and the boat rocking inside the channel, etc. And we also have to create the path where the boat flows and simulate where the boat, or how fast the boat will go through the channels, since one of our main work revolves around calculating the theoretical capacity of some of those rides, and we have to know what the dispatch will be, how many boats we need, etc. And also, interactive boat ride. As you can see, there's also a steel channel in there. That's a track, and that's also something we have to design. Spinning rides or Mack Rides is one of the major manufacturers for spinning rides as well, or spinning coasters. Since we actually have a train configuration spinning coaster for a very long time, and there's many installations of that smaller spinning coaster variant. These kinds of rides introduce another dimension of motion, which we have to consider in our ride design. And we actually have to turn down a little bit the intensity to still have this a family experience. We scaled up the spinning coaster concept in 2018 with Time Traveler in Australia and more recently the Ride to Happiness in Belgium, where we threw that out of the window and said, let's go crazy with spinning rides or spinning roller coasters. And we do inversions with that, and we actually can do chain lifts and LSM launches on that ride type as well. And then there's the final boss of layout design at Mack Rides, which is our inverted powered coaster, Arthur at Europa Park. And that's because it's not only a track, it's fully programmable ride velocity on a motorized vehicle. There's fully customizable and programmable rotation of the gondolas, and all of that has to be considered since this ride lives and dies with the story it tells. So we have to coordinate with the client where they want to put the scenes, how long those scenes are. This type of ride also has a block system, which is very different from all the traditional block systems of gravity-driven rides. And this block system is, the calculations behind it are very sophisticated and complicated. So every engineer at Mack Rides, or every layout engineer at Mack Rides really sees a challenge if they have to do one of those things. As I said, final boss. Okay. As you can see, there's a whole bunch of different things to consider, and we want to have we want to boil down everything into abstract concepts, which can be applied again with those ride types, which helps us actually use this one software package, which is basically a toolbox of which our ride designers can put different tools, individual tools, which fit the requirements of those ride types, and then assemble them and use that to do the layout design. And I hopefully won't bore you now, so just please shout out if I lose you now. So a track, each section of a little track is basically specified by its position inside some coordinate system, X, Y, Z. And also its orientation. So there's the yaw orientation, which basically specifies if I'm looking to the east or west, north, south. Then there's the pitch angle, if I'm looking up or down. And the roll angle, that's basically the angle that we see the horizon in at each point inside the track. So for the outer bank turn, the roll would be 90 degrees because we see the horizon not level but vertical. And there's actually some constraints on those angles, since not all rides can be in all attitudes at this, like the mega coaster here, Hyperia, which is basically completely unconstrained when it comes to orientation. Our powered coaster, for example, is motorized, so we have to limit the inclination angle of the track. White mice don't have the kind of actuation inside the coaches, so they can't really do rolling motion. So the attitude of those coaches are actually constrained, and we have to keep that in mind that we can't do powered coasters with 45-degree inclination angles. So that's the first type of constraint that we can introduce when it comes to layout design, and that's the first thing that we have to keep in mind when we actually do a layout design. Going one step further, and we look forward into the track from any given point, the track changes in its orientation, and that's all a track can do. There's 3 degrees of freedom. If we go 1 meter forward, I can turn left or right, that's 1 degree of freedom. I can turn up or down, that's the 2nd degree of motion, so yaw motion, pitch motion, and again roll motion. And those correspond basically to the radii that you can see in the track, like left turn, right turn, up or down, and the track twist that you experience so often in the Hyperia as well. And each of those motions, or each of those radii, is also constrained, and as Maurice already said, we do multi-body simulation of the actual orientation and location of the coaches with respect to each other, and at some point those things just collide. Or there's a pinch point, like here. And these attitudes of the coaches correspond to basically combinations of radii that are right on the limit of what we can do. So there's basically for each combination of left turn, right turn, hilltop or valley, or track twist, some limiting assembly inside the train that says like, no way, you can't go any tighter than that. And there's several kinds of those, like if we have a heavily twisted track, like the running wheel of one coach goes basically into the kick plate of the other, and there's actually some kind of hole in there to allow for more actuation between those two coaches. But at the end, we can say we have a whole bunch of combinations of radii that basically are the minimum radius that we can do for each type of roller coaster, because there's like all sorts of different ride types. And we know which kind of combinations are valid and which kinds are not. And those are just the purely geometric constraints, and that only scratches the surface, don't worry. Yeah, let's introduce train velocity, since right now it's only like we put a train on the track and see how it just bends inside the track. If we introduce velocity, if you're familiar with physics, we have a velocity, we have a radius, you get centrifugal accelerations, and that's the main source of thrill for all those kinds of rides. Like that's what makes you scream on the roller coaster, having varying and interesting combinations of accelerations. But they are also limited, and the limiting factor is usually the ASTM, the EN, the GB, the standards that we have to comply with. But not only those, especially for family type rides or kiddie rides, it doesn't make sense to expose those kids with 6Gs. They wouldn't have fun. So for us at Mack Rides, we have basically product internal acceleration limits that says we don't have to really calculate a spinning or a kiddie coaster coach with 6Gs. That steel structure would be massive. We can actually reduce the amount of steel that we put into a kiddie coaster, a youngster coaster train by calculating only 3Gs, 2.5 Gs. So for each type of ride, we know which kind of accelerations make sense, and we try to comply with those internal standards. The international standards also not only constrain our combined accelerations in the XY plane, XZ plane, and ZY plane. They also constrain, as Maurice introduced also for Hyperia, the duration of all of those accelerations. And they also constrain the jerk, so the derivative of the acceleration, which is basically how fast you can change the accelerations. And all of those things have to be considered when doing layout design. It's quite a bunch of things to have to keep in your head when doing these things. Going from internal to external constraints. So far we have only looked at the track and its local environment and what kind of experience we have and the geometry of that. Now we put the track inside some kind of environment, and we have to make sure that there's no interference between the environment and our track, which is also limited or constrained with the international standards. There's a clearance envelope, there's clear instructions how to construct this kind of clearance envelope in each of the standards. This is one of the drawings that we do for each of our ride types. That's actually a different department that gives us this kind of drawing. And then we sweep that profile along the track and see if there's any intersections and collisions, and those are no good. And for some ride types, like the water coaster, as I've said earlier, there's like steel track at some point, and then we go into a free-flowing channel, and there the boat can rock and go and sway and do all those things. And in those regions, the clearance envelope is actually different, and we have to take that into account as well. For some other standards, the clearance envelope also changes or we can also change the clearance envelope when it comes for slower moving sections, because the risk injury is lower there. So usually in the station, these kind of constraints are a little bit fuzzy. And under some circumstances, if there's no pinch points, etc., if the risk for injury is very, very low, you can actually reduce these kind of clearance envelopes as well. Yeah, and then there's all the other kinds of external factors and constraints that are usually project specific. And Maurice already told some of them for Hyperia, like the site which didn't allow for a straight drop into a huge airtime hill because there was the park's boundary. There's always a project budget, there's a target capacity to hit. There's some other special requirements for water coasters. We have to introduce like some water flow and see where the pumps should be, have like overflow channels, etc. And yeah, you have a very interesting park here in England, which has very interesting constraints, which is Alton Towers, and they can't build above a certain height of the coasters, which is also a kind of constraint that is really interesting. And constraints always facilitate creativity in a way, which can be seen in something like Helix at Liseberg, one of our launch coasters, which is built on a hillside, which is a very unique layout, and in my opinion also one of my most favorite ones. Let's talk about capacity for a minute or five, because that's a really, really important number that's always talked about, and there's a huge variety of capacities that we want to hit, and since some of our ride types, like the water coaster, only contain like eight people, hitting like really high capacities is a big challenge. And that's why you see a lot of different kinds of station layouts inside the whole industry, of which I just show three, which is the separate load and unload station here. I think this is Manta at San Diego, but correct me if I'm wrong. Then there's Cobra's Curse with a slow-moving creep mode station in Tampa. And we have something like our water coaster in Europa Park, which has actually 2 load and unload positions in sequence. So there's always 2 boats being loaded and unloaded at the same time. And we see those kinds of stations because usually the station is the block with the longest block time. What do I mean by that? Like, is everyone familiar with block zones in this audience? I see a lot of nods. Who is not familiar? Just raise your hand. Okay, perfect. So, THRC is basically a theoretical hourly ride capacity, is determined by 2 factors. It's one, the number of passengers we can fit into each train, and then the dispatch time. Those are 2 variables. Usually for trains, we can always increase the train length, and thus also the amount of seats that the train can accommodate. For other types, it's fixed, like the water coaster. So usually, there's not much to do there. So the other number, the theoretical dispatch, is really important. And since the station is usually the limiting factor, since the block time of the station is the limiting factor, if you want to have a target capacity of, let's say, 1,200 people, and the theoretical dispatch is 36 seconds, the operators really have to be on their feet to get that 36-second dispatch. And we can help them, for example, by splitting up load and unload, since the loading people don't have to wait for the unloading people. And in that way, we can actually reduce the load time required in that station. Those also might come with their own special requirements, since in Tampa, for example, accessibility was a huge topic, and such a creep mode station naturally isn't accommodating for people that are not so easy on their feet. So accessibility can also be, we have to do a different kind of solution for accessibility, and you have to look at the bottom left. There's actually a separate station in Tampa for accessibility for disabled guests, which is in front of the creep mode station. There's a sliding track switch, which contains two tracks, and we can put a train on there, slide the track over, and have all the time in the world to unload and load a disabled guest. That train leaves a slot inside the cycling trains, which can just slot right in, back after one cycle, do its cycle, slot right back into the accessible station, do the unload, and then just slot back in. And that's basically a lot of thoughts go behind this, with some other special types of operations that you can see in the top right, which is a simulation, a very fast simulation of Cancan Coaster back at the Europa Park. This coaster has a separate station for VR operations, just because VR, they wanted their own VR experience inside the station. So if you haven't experienced that one yet, spoiler alert, you will take on your VR goggles first, before boarding the train, go inside the station, and board the train in VR, in that kind of ride. So this naturally requires a whole separate station for the VR guests. And one of the main things was that there was no space inside that indoor coaster, so we had to basically build a whole different station outside of that thing. And that poses the challenge of how do we do this slotting of the trains, since we were so constrained with the location and etc. And we actually came up, after days of thought, with a solution with a single rotating track switch, as you can see here. And we didn't really want to lose capacity. For the Cobra's Curse thing, the train that slides out leaves an empty space in the cycling trains. In the Eurosat case, we basically do a hot swap between two trains. Let's see if we can catch one. I think it's this one that will slot into the station. And the pink train will take over the slot of the dark blue one. So we don't actually lose any capacity by doing that. And there were a whole bunch of Excel sheets calculating which kind of configurations we can do. The simulation shows like 5 normal trains and 2 VR trains. We can actually do also combinations of 4 trains with 3 VR trains, 3 trains with 3 VR trains, etc. In a way that we don't actually lose capacity. Doing this kind of considerations without any kind of simulation is really tedious and prone to error. So that's why our department is called Layout Development and Simulation, since simulations really help us do all those crazy things. Yeah. Now to the fun stuff. This was the compulsory exercise, if we're talking about like figure skating. We haven't talked at all about the free coasting parts, etc. And those are actually the creative, that's the creative part And our biggest problem that we face day by day is that we are so overwhelmed by all the constraints that there's no room for creativity anymore, since we have to think about, the project budget, there's a very constraining site, we have to hit the target capacity, etc. Have you thought about like the minimum turning radius, etc.? So that's why we started our own layout development software, which should facilitate all of those constraints and make it as easy as possible to have a good overlook over everything. And in that way, we facilitate creativity by offloading all the work, all the tedious stuff into that software. Layout design traditionally stems from railroad design, and you can still study that stuff in civil engineering in German universities. I'm not sure if that's still in the UK, but there's like actual studies of civil engineering and railroad design right now, in which you can learn like how to do railroads the old traditional way. And since roller coasters basically stem from railroads, for a long time we used the same kind of methods, which is based on 2D drawings. We have a projection from top down, draw basically the layout using straight lines and circular arcs. Look how long that layout is, put that on the x-axis, and draw basically the height profile, the contour profile of the track down there. And then the last degree of freedom would be the roll angle, which is displayed right here. So we can actually use 3 2D drawings to specify a whole 3D track, with the big disadvantage that nobody has any idea how that track will look in 3D, especially for roller coasters, which have widely different geometry, and the geometry is like a whole more complex than those of railroads, as you can see down there. You get a beer from me if you know which kind of coaster which coaster that is. That's a nice challenge for you to figure out which coaster layout this one is. And as you can see, those kinds of drawings are still there, but we don't actually use them to design the layouts. Nowadays, this is all fully integrated in our 3D simulation program, where we do the layout design, the layout geometry. Has anyone ever played No Limits? Raise your hand. Okay, you can think about that in hardcore actual layout design. Something like this we actually use to do our layout design. And yeah, this with a big aim to really facilitate creativity by allowing rapid iteration, like giving the designer immediate feedback, so that you can see the track in real time change, evolve, sit down inside the POV and write each element like with rapid succession. And this kind of rapid iteration, rapid feedback of like the POV layout and the accelerations, etc., really helps us like explore the design space as much as possible. Let's do an example. This is the non-inverted loop from DC Rivals Hypercoaster in Australia. And that's basically the first step, design the centerline geometry of that 3D track. That's the hard line of DC Rivals. And by doing that, we specify basically where the track is at each point along the track. This is only positional information. We don't know what the orientation of the track is yet. but we do know what the curvature is, so the inverse radius at each point along the track, and we can plot that, and we can see that this is pretty smooth and continuous, which it should be because modern roller coasters are, or modern steel roller coasters are expected to be smooth. We can go one step further and specify at which points along the track should be oriented in which way. So now we go from the yellow hard line down to the track center line, which is the blue line there. And then we can see, yep, it's not a regular looping, it's actually a non-inverted looping. And this splits up the radius that we saw earlier into 3 dimensions. The blue one is the vertical track radius, so the up-down pitch motion. The yellow line is the left-right motion, and then the twist of the yellow and the blue basically gives us the twisting motion in the roll. And yeah, we can also draw the whole layout in 3D, the whole track, which gives us a good impression of what the layout would look like if we just stood there and have a look. Since a lot of park guests don't ride those tons of rides, they still want to enjoy them by having a good look, and it should look. There should be some aesthetics to those kinds of rides as well. Then we do a ride simulation, and I don't have a video here, but we can actually simulate the train going along the track, calculate all the accelerations, have a POV, etc., do modifications to the track, do a POV again, see if it improved, etc. Yeah, the clearance envelope is also shown. We can see if there's any collisions there. And hopefully, years after doing all those considerations, that thing will be built. And then millions of riders enjoy the coaster. And I think DC Rivals opened in 2016, 17 or something. It will have hit 1 million riders by now. So thank you. And we will go ahead with questions and answers. And I think Chris will have something to say as well. Thank you.
What's up? Sam Costello, a massive super fan of Europa Park. I've never been, but that's just details in it. You mentioned earlier you got a bit mad with the spinning coasters. We got a bit of a mad coaster out there, Hyperia, perhaps you've heard of it. Would you put a spinning seat on the back of that? Like, is it realistic?
So I can talk about theoretically what has to happen in order to verify if spinning is possible, and Maurice can maybe answer the question directly because I'm not really completely aware of what the acceleration profile is, etc. But yeah, it would be mostly the clearance envelope, since I'm not 100% sure if that's the same clearance envelope, and if we considered using the bigger clearance envelope a priori, and the accelerations. Since the spinning seats basically gets us a chaotic output of the XY accelerations of the coaster, we have to make sure that every combination and every orientation along the track is valid inside the EN standards. So those are the things that we would have to do. That would be our homework to verify if a spinning seat would be possible. But I think it would be.
Yeah, it's the same. I also think it could be. I'm also not quite sure. As the clearance envelope to the columns is at some points quite difficult, a bit too narrow. But yeah, just theoretically, it is possible. Yeah.
Like those spinning coaches have been developed to use approximately the same clearance envelope. So the answer is maybe. Backward seats, definitely. So it's theoretically possible to put backward seats in there. You have to ask Thorpe Park. We would appreciate the contract.
Hello, what is your favourite Mack product?
That's an easy answer. Right to Happiness, obviously.
Yeah, for me also easy, it's Hyperia, so also an easy one.
What would be your second?
My second favorite Mack product, flying fish, of course. I have to think by probably Voltron. Because I'm not so into spinning, and so Voltron does not spin, obviously. Yeah, probably Voltron, yeah.
I should exclude Voltron because that's also one of my designs. And then the second place would go to Helix, probably.
Hello, is there a coaster designed by a different manufacturer that you love or like you wish like it was your idea instead of theirs?
Janica.
I really love Iron Grazi.
Who doesn't, really? Maybe one day we'll get an RMC at Thorpe Park, but yeah, we're about Mack tonight anyway.
But maybe you have figured by now I really love spinning in all kinds of directions. So.
Hello. Okay. With obviously steel construction, there's pretty tight tolerances on it, and when you take in groundwork as well, they tend to have fairly big tolerances. How do you manage that between the teams that are obviously preparing the ground to when the track turns up?
Yeah, so our advantage is that steel is a bit flexible, so you can push it to where you want to have to push it. But there are always also the groundwork and also the anchor cages have tolerances that shouldn't be too big. So of course columns that are, for example, not as high, you can't move really much. But for example, the steel structure of Hyperia, the columns of Hyperia are, have a really long extrusion. They're really long and high, and so yeah, you can even tilt them by a degree, and it will nothing happen.
Yeah, we can tilt them because like the connection between the base plate, the steel base plate, and the foundation, the holes that connect them are bigger than the nuts and bolts that go through. So there is some leeway to accommodate for the different tolerances between the concrete structure and the steel structure, and we can actually tilt and move the base plate inside the foundation before we pour down the final concrete. And that's basically how we go around with those different tolerances.
I know I'm probably opening up a big can of worms here, but with FVD++ and the proprietary software that you have, what are the similarities and what are the differences?
A whole bunch of, like, basically everything in FVD++ is in our proprietary, that's a damn word, in our software. And we've expanded like the whole feature set. As I've said, like FVD++ is a tool, and our software is a toolbox, of which FVD++ is basically a tool. And the designers can pick and choose which tools are the best fitting for their purpose. So it would be like it's expandable, and there's a whole bunch of things that, like, in No Limits you don't really need, that real roller coasters do need, and that's why it's a whole package. Yeah.
I've always been someone who prefers or really appreciates theme in my experiences. So I'm interested, how much do you know of a coaster's future theme when you take over a brief, and how much do you let that affect the design choices that you make when designing it?
The answer is really boring. It depends. And it really depends. Like sometimes we have a whole storybook given to us by the client, and there's a whole bunch of designers that had days of work, months of work before we even started to write that storybook and give us as much creative input as possible. And sometimes there's like parks that have, we have a green field there, build us something. And that's the amount of like, that's the span that the bandwidth that we were working with. The industry is really diverse, from like super small parks to like the huge Universal, Disney, you name it. And yeah, in that regard, the input that we get is also very, the bandwidth of the input that we get is very big.
Hi, so I'm an aspiring like ride designer. I was just wanting to know like what's the best way to get into like working for a company such as Mack, designing rides, or any other company?
Yeah, that's probably the most asked question that I get, and I really don't know. You have, or my history or my experience is that you have to make yourself known. You have to make yourself get out there and share your ideas, and hopefully someone will recognize that your ideas are somewhat okay and maybe warrant a full-time job. But the honest answer is basically by chance, honestly. Since the industry is so small and the number of applicants for each job entry is like huge, you have to be really lucky. Like even if you're like super gifted, super talented and have the best ideas, it's still super tough. And that's the honest answer. Do you have anything to add?
Yeah, at me it was luck at all. So yeah, it was the right timing. Mark was searching for new layout designers, and this was exact the time where I finished my studies in mechanical engineering, and yeah, so I really wrote one application, and this was to Mack Rides, and yeah, it somehow worked out. Yeah, it is a bit of luck. Of course, you have to be good in what you're studying, or you have to have a good feeling about roller coasters. You should be interested in roller coasters, but at the end, yeah, it's a bit luck. It's a bit good timing, a good profession. Yeah, a combination of all these things.
Is there any Mack products that you haven't worked on but you wish you did?
Helix. Yeah, Helix. That was actually before my time. And that's like, that looks like the most fun you could ever have, with like this hillside and design a ride around that hillside. That's really unique. Also, interactions with a whole bunch of other rides. Those are the kinds of constraints that really help like come up with creative ideas. And I was lucky enough to actually be involved in a similar project with a hillside and really interesting terrain, which was Time Traveler. But I think Helix would have been like even more awesome.
Yeah, my first thought also was Helix, but additionally DC Rivals would be quite interesting, because I love high roller coasters, and I think it's quite a good layout. It's yours, right? Yeah. So, yeah, but this was also before my time, so Stephan is a bit longer there. And yeah, probably Helix, and after that DC Rivals.
Good evening.
Good evening.
Of the original 9 layouts for Hyperia, which is your personal favourite?
I'm really, so the first one you have seen, and I think the first 3 or 4 I haven't been involved, so these are not my favorite, of course. But in the end, really, we have worked so much on this layout, and it would be a pity if it isn't this layout we have now here at Thorpe Park. So yeah, I can really honestly say it's the best layout we have done for Hyperia is also Hyperia now.
Yeah, like each layout designer works hundreds of hours on those layouts, right? So it would be a pity if it wouldn't grow on him, that kind of layout. And I'm avoiding to answer your question because I don't know all the 9 versions, since I had other stuff to do and I haven't actually looked at all those nine layouts. But probably, yeah, the last ones, because that's like the most highly optimized one. And yeah.
Hello guys. Brilliant job with Hyperia. I like rides where my bum is off the seat, and that is one of the best rides where your bum is off your seat I've ridden in a very long time, so thank you. I've got a question that's very similar to the one that was just asked, but it's a bit of a build on it. If your client Merlin had given you another 20% in the budget for this ride, what would you have spent it on?
Never really thought about it, but of course it would be a bit longer. Probably after the trim brake, because there you have a good velocity to do even more elements. So maybe go a bit out to the outer bank turn again, but which elements or something, this was never in discussion to make it longer, so I have no answer that we could say this element I would have to love, but it would be something with a lot of airtime.
A 6th coach, but I think, yeah, the 20% budget wouldn't go to Mack Rides, because like the 6th coach would increase the maintenance area, would increase the station building, etc. So most of the budget wouldn't go to us, actually. But the 6th coach would help you, like, imagine the back row experience on the 12th row on that thing.
Wouldn't be in the standards.
Wouldn't be in the standards? Okay, yeah, some reprofiling maybe.
Hi there. Dueling coasters, are they more difficult to design, and are either of you two involved in the dueling coaster at Epic Universe?
For the second question, no answer. Sorry. For the first question, yes, they are. Is that enough for you, or should I say some sentences? Yeah, obviously they are difficult, more difficult to design, because there's like a whole different dimension of other constraint that you have, which is they should duel, and there's like double the work. So yeah, it's very difficult. Like Max and Moritz basically is a good example. There it was easier because it's 2 powered coasters and you can play around with the onboard motors a little bit to make them dual a little bit more. But I think this actually wasn't needed for the final version of Max and Moritz, since the track lengths are basically identical, and if those trains go the same velocity, they do the whole thing and dual. Yeah.
So we know that you can't say a lot about Stardust Racers and Curse of the Werewolf, but how excited are you to have 2 new designs in what will be one of the world's most famous theme parks?
Oh my gosh. Yeah, very excited. As excited as a German can be.
Genau, danke schön.
Hi. In the last 100 years, what do you think has been the most important innovation in roller coaster technology?
The popular answer would be the clothoid looping by Werner Stengel. And I would say that's pretty much right, yeah. He was the first one that actually did that whole projection plane that I talked about earlier. And took a spin on it by not using the top-down projection, but used that projection and actually designed the looping with the same methods, but with different projection planes, which is really clever and shows that he's a very good engineer, that he thinks outside the box. And with that, the whole suite of like layout design tools came to be. Like that's all Werner Stengel's work. And I would say, I would go so far as to say that modern steel roller coasters would be like maybe 10 years back in their development if it wasn't for Werner Stengel. Anything else?
Nothing to add. Maybe if we don't go as far as 100 years, but in the newer past, I think all the outside bank elements are getting more and more, and especially RMC, I think, pushed all through the others to do more outside bank and to do even more like crazy elements. And maybe, I don't know, maybe even Hyperia wouldn't have such a great outside bank if not the last years this developed more and more for all coasters.
So the short answer is Alan Schilke and Werner Stengel.
So we have a lot of elements that have specific names. Do you have any names that you've given to the outer bank, as it is something so different from anything else we've seen before?
So the internal name is the Kremer Rolle. It's Kremer roll in English. By his name, Kremer, by his surname. I don't think there's an official name. And that's really interesting. As he already talked with the last question, with all those crazy elements, it's really hard to like distinguish them, and like the wording gets really fuzzy. And if I'm talking about like a wave turn or something like that, or whatever all those names are, I'm not even familiar with all those new inside out whatever flips. At some point, it doesn't really make sense to name the elements anymore, since at some point, like every element has its own name, and that's like, it's what's really the point in like putting things into categories if the category only contains one element. Those are mostly marketing terms, I would say, and that's the new trend, that it's really difficult to describe all the elements that we do because they are so weird and fuzzy.
I think there's no official name, but you will find in all the drawings, etc., that we made, the really boring name outside bank turn. That's it.
Do we not feel, though, that it should be called the Kremer roll, you know? It's very well deserved.
What's the craziest element you've made that even internally you went, that's a bit wild?
I have to think. Do we have one on the top of your head? The thing is, like, most of them have been realized, actually. For me, I think it was the banana roll on a spinning coaster, because that was like, can we do that? And we could, so we did.
For me it was at Hyperia one time the first job, but especially our called outside bank turn, of course.
Kremer roll.
Or what you say. Yeah, I think this was also the element we worked the most on this layout, and yeah, so this one.
Hi, I'm Henry. Thanks so much for coming over and talking about so many of your experiences. Ride Happiness is a perfect coaster, and Hyperia is also up there, so thank you very much for giving us these amazing rides. You talked a lot about your software and safety and tolerances. How much, if any, is there some physical input into like freeform designing and kind of like really creative layouts? Does that kind of still exist, or is it straight into kind of like the digital designs with the tools that you've got?
First of all, thank you. And maybe I botched the answer completely because like it was really long. The question was really long. But let me just give some thoughts about like layout design, software, etc. And it's basically the same answer. We have a toolbox. Like there's a whole bunch of tools in there, which include, you put in, give me 4Gs, vertical and no laterals, etc. And it designs you the perfect valley. Another input could be like, give me minus 1.2 Gs sustained on 90-degree banking, and it gives you the perfect outside banked element. Another input could be, there's a wall there, we can't go through this wall, put the track right there, and with this orientation. And basically the end goal should be, and if anyone is familiar with software engineering as well, that the design should be self-documenting in such a way that another designer can open up the model and see what the design constraints and what the design intent was. So if I open up Hyperia's model, it should be obvious that the first drop is limited by the back row ejector airtime. Then the roll down is limited by the angular rates in the back row. The first valley is limited by the 4Gs, and then the terrain height of that section in there. And I don't even have to talk about with Maurice about that design. I can see that inside the software what the design constraints were. So self-documentation is very, very powerful in that it is both like a conscious decision to shape the track like with this constraint in mind, and it's some kind of self-documentation when some other designers look at the design and see, okay, that was his intentions. Was that a good answer? Do you have anything to add, Maurice?
No.
Okay, perfect.
Wasn't that fantastic? What we must say is Thorpe Park and Mack Rides have brought a masterpiece, haven't they, to Thorpe Park? You know, we're very lucky, we're very grateful for what you've created, and you are absolute masterminds of your trade, and you've explained that to us really well today. You know, so we're so grateful for you coming over, you know, all the way from Feldkirk over to the UK to share your expertise with the community. So again, a huge round of applause for Stephan and Maurice.